Welcome to Euclide Academy. In this video, we are going to solve the 2021 Science Paper 2. And in this paper, you have well over 2 hours allocated to you to solving this paper, and you've got 85 marks in total, and you've got 3 sections, section A, B, and C, and we're going to start with section C. So without wasting much time, let's get into it. The branch of chemistry that deals with substances and processes in living things is known as, we've got A, biochemistry, inorganic chemistry, organic, and physical chemistry. So when you talk about processes in living things, and basically we are referring to some biological aspect of it. So the best answer here will be biochemistry. Biochemistry is the one we studied, which is involved studying substances and processes in living things. So that would be the answer. And then we have question 2. The following graph shows the cooling curve for a substance. Okay, so this is the cooling curve for a substance, so basically this is talking about changes of state. You've got the temperature here, you've got the time here. Which of the following gives the correct state for a substance at P, Q, and S? So we're talking about the state for a substance at P, Q, and S. So if this is the cooling curve, so the cooling curve shows the changes from gas to liquid to solid. So we can have a substance being as a gas here, then as a liquid, then as a solid right there. So which of the following gives the correct state for a substance at P, Q, and S? So at P it can be a gas, at L it can be a liquid, and at S that should be solid. So you can have liquid, and gas. So the correct one here would be gas, liquid, solid. So we're going to go with gas, liquid, solid, which is C. So for 2, we're going to go with C. A3, which test could be used to show that a sample of water is pure? It freezes at exactly 0 degrees Celsius, colorless and tasteless, neutral to litmus, changes anhydrous copper to sulfate from white to blue. So the ultimate test for water will be how it freezes over boiling point. So basically the freezing point, because impurities can actually alter the freezing point. They can change the temperature at which water freezes. So if it's pure water, it will definitely have to freeze at 0 degrees Celsius. So this would be the best option right here. Question 4. Oxygen atom and oxide ions are dash. Oxygen atom and oxide ions. So chemically identical isotopes of oxygen have the same number of electrons, have the same number of protons. So we know that oxygen atoms are basically this. An atom is stable, and an oxide is the one which is not stable, because they have actually gained some electrons. So an oxide ions is an oxygen atom which has just gained electrons, so it has got a charge. These are just charged atom. A charged atom is called an ion. So an oxygen atom which is charged is called an oxide ion. So what will be true about these two? Are chemically identical, are isotopes of oxygen, have the same number of electrons, have the same number of protons. So the best option here will be they have the same number of protons, despite one gaining electrons and becoming charged, but the protons remains the same. So the answer will be D, and this would be the answer that we would go for. So in this one, we'll go for D. Okay, I can't really go down there, so for 4 our answer is D. I'll just put it here. So this is D. Question 5. Which set of properties describes those of an ionic compound? Which set of properties describes those of an ionic compound? So let's talk about conductivity in molten state, solubility in water. So we know that ionic compounds, definitely when it comes to conductivity, they're very good, since the ions are mobile. So we can definitely rule out D and C, and then we have got A and B to contest for the final answer. So solubility in water, so ionic compound are soluble. So A will be the correct one here. 5. The relative formula mass of copper 2 sulfate pentahydrate is, so this is the compound we are looking at, copper 2 sulfate pentahydrate, which has got this chemical formula. What is the relative formula mass? So the relative formula mass is the total mass of the relative atomic masses of an ionic compound. So this is the ionic compound, so we're talking about the total mass of the relative atomic masses. So we have to find the relative atomic masses here, then find the total mass, and that will give us the relative formula mass. So you might be thinking about where we're going to get the relative atomic masses. So well, this compound is made up of atoms, and the good thing is that you have got all the relative atomic masses listed on your periodic table, so you can check the relative atomic masses, and then you find the total mass, and then see what you have here. So what we're going to do is that we're going to go to our periodic table. So this is our periodic table. So we look at the relative atomic masses of our compounds right here. So we've got copper, sulfur, oxygen, hydrogen, and oxygen there. So we want to find the relative atomic masses. So we can find them here, and then we add them, and then see which ones we are looking for. So we can say this right here is the chemical formula of our compound. So we're going to check the relative atomic masses of these, find the total relative atomic masses here. So for copper, we can check copper is here. We've got 64, so we're going to say 64. We're going to add sulfur. Sulfur is right here, 32. We're going to add 32 plus we've got oxygen. Oxygen is 16. It should be here. Then 4 of them, so we're going to multiply by 4, and then we're going to add 5 times this times water, or H2. We say that is hydrogen, that is 2 of them, each is 1, so that makes 2, and then we're going to add this plus oxygen, again 16, and then we multiply everything by 5 because there's a 5 in front. So when we put this on calculator, and that should give you 250. So the relative atomic mass formula mass of this ionic compound should be 250. So we come on to a question, we check if we have what we're looking for. So we have 250 on D right here, so this should be the formula mass we are looking for. Question 7. Why is ethanoic acid described as a weak acid? Okay, so weak acids, they are weak because they ionize partially in water. They do not completely ionize. That should be the main point. So don't talk about electricity or organic acid or react with metals. So C should be our answer here. An acid is weak because it ionizes partially. An aqueous solution of aluminium chloride is tested with some reagents. Which of the following observation is correct? Okay, so we've got aqueous solution of aluminium chloride. So here we're talking about the test for cations. So we've got we are testing for aluminium right here. So what is the test? You need to know the test for cation for you to be able to answer this question. So what are the reagents that we use? So mainly we are going to use, when we are testing for cations, we probably use aqueous sodium hydroxide or aqueous ammonia. And when we use aqueous ammonia, we're testing for the cation aluminium. It produces a white precipitate, and which is insoluble in excess. So these are the things that probably you should memorize or master if possible. There's no harm in it. You have to put them in your head. You have to master them. So there are only a number of cations and anions which you can memorize, and that can really help you. So this question will test you on how well you know the test for cations and anions, that is qualitative analysis. A solution of sulfuric acid has a concentration of 0.25 mole per 0.25 mole per decimeter cubed. What is the mass of the acid in 25 centimeters cubed of the solution? So in this question we are talking about concentration, and the thing that we should note here is what is concentration. So concentration is, we talk about the number of moles, the volume, so that is the concentration. So we're looking at how much of a solute per cube decimeter that we have in a solvent, so that is the concentration. So concentration right here is, they've given us the concentration of this the solution of sulfuric acid has a concentration of 0.25, which is, so we're just going to say the concentration is 0.25. and what is the mass of the acid in 25 centimeters cubed of the solution? So number of moles divided by the volume. So we've been given the volume right here, but the volume that we've been given is in centimeters cubed, and want it to be in decimeters cubed because the concentration is in decimeters cubed. So we're going to divide the 25 centimeters by 1000, and that will give us a 0.25. So 0.25 we'll say now is decimeters cubed. Okay, so now this is our volume, so we're going to put it here is a 0.25 decimeters cubed. So now I want to find the number of moles, and simply here we cross multiply. So number of moles is going to be equal to 0.25 times 0.25, or 0.25 squared, and then this should give us 0.0625 moles. So those are the number of moles that we have of the acid in the solution. So the question says, what is the mass of the acid in the solution? They don't want the moles, so we now have to convert the moles that we have into the mass, and we know that moles, the formula, moles is equals to the mass divided by the molar mass. So in short, for us to find the mass, we're going to multiply the number of moles by the mass. So for the mass is equals to the number of moles, we have got 0.06 0.0625 times the molar mass. So what is the molar mass of sulfuric acid? So sulfuric acid, you need to know the formula. So sulfuric acid is, so for sulfuric acid we've got H2. This is the chemical formula for sulfuric acid. So when we use the chemical formula to find the molar mass, so that will be H is 2, so that will be 2 plus S is 32, sulfur is 32, and oxygen 16 times 4. Okay, so when we find this, you can get your calculator and you will find in a bit, then that gives us 98. So the molar mass of sulfuric acid is 98. So this will be 98. So we're going to multiply the number of moles times the molar mass, 98, to find the mass. So to be 98 times 0.0625, which is the number of moles we found, and we get 6.125. So you get the answer as 6.125. So this is in grams. So this, and then we look at the answers. We've got 0.6125, we've got 1.25, so 61. So the probable one will be 6.135, because we can round up the 2 there to have 5, to have 3. So this will be the answer, C, 6.130, which is the same, which is just rounding up 6.125, and C will be our answer here. The following graph was obtained in a reaction between dilute hydrochloric acid and magnesium ribbon. The volume of hydrogen in centimeters cubed, and we've got time here in seconds on the x-axis. And then we want to, the question says, what was the average rate of production of hydrogen? So that's the question. What was the average rate of production of hydrogen? So the rate of production from this graph, we can see that we've got this line here which shows the production and at what time. So if we find the gradient of this line, that will give us the rate of production. So we can pick 2 points and then use those 2 points to find the gradient. So I would like to pick 0, 0, and the furthest this will be 30, 60, and you can pick any 2 points, it's up to you on this line. And then the gradient will be 60 minus 0 divided by 30 minus 0, and that will be 6 divided by 3, and that will be 2. So I would go for 2 centimeters cubed per second, 2 centimeters cubed per second, and that will be C. So I will go for C as the rate of production of hydrogen. Just find the gradient of this line. You can pick any 2 points. Element T forms an amphoteric oxide of the formula T2O3. In which group of the periodic table is T likely to be found? So the element T, which an amphoteric oxide is actually formed by, is an oxide of metals, and to be specific, transition metals. So in which periodic table is T likely to be found? So in short, where do we find the transition metals? So we can find it's not group 1 or group 2 and not group 5. So basically these are basically non-metals. So we can find group 3, we have got some transition elements there. So probably it will be C. Which of the following is the distinctive property of a transition element? So you can even see how the questions are following each other on one particular topic. So you can actually even relate the questions. Which of the following is a distinctive property of a transition element? It, okay, is a good conductor of electricity, has high melting point, forms colored compounds. I would go, it has a variable valency. Okay, this is one distinctive property that varies. That's when you have metals like iron 2, iron 3, aluminium 1, 2, 3, so such compounds. So these are transition elements, and hopefully there are actually those transition elements I've mentioned. Hope they exist. And anyway, so that is it. So has a variable valency. The following table shows the protein number of 4 elements represented by the letters V, W, Y, and Z. So element V, W, Y, and Z, proton number 9, 11, 17, and 19. Which of the following statements is correct? V is a metal, V is more reactive than Y is more reactive than Z, Y and Z are in the same period. So what would help us is to to put the electronic configurations of these metals. So V, the electronic configuration is going to be like 2 in this first shell, then 7 is outermost shell, and then for W it will be 2 in its first shell, then it's going to have 8 in its second shell and 1 in its third shell. And then for Y we are going to have 2, then 8, then we are going to have 7. Then for Z we are going to have 2, then 8, then 8, then we are going to have 1 is the other shell, the outermost shell. So let's look at the statements again. V is a metal, so V is not a metal, it has got 7, so this one is looking for a proton donor. V is more reactive than Y. V is more reactive than Y, so not really, we are seeing they've got 7, so it's not correct. W is more reactive than Z. W is more reactive than Z, not really, because we can see the 1 in the, we have 1 there. Okay, Y and Z are in the same period. Y and Z are in the same period. Okay, so looking at this question again, V is a metal, so V is not a metal, so let's use a cancellation. We try to cancel, so we can cancel this. That's not the answer. V, okay, let's see to C. W, because I've got a special spot for C, I think it could be one of the answers. W is more reactive than Z. W is more reactive than Z. This is not true, because Z is, they are in the same group, but this one will be more reactive than this one, since they just want to lose this electron. So Z will be more reactive, so C is not the answer. D, Y and Z are in the same period. It's not also true. Y and Z are not in the same period, so V is more reactive than Y. It could be the answer, because yes, they're in this, they've got the same number of electrons in the outermost shell, but this one is on top of this element, so this one will be more reactive. This is a halogen, and halogens get more reactive as you go up the group, which is a different with alkaline metals. They are more reactive as you go down the group, so this one will be the answer. And aluminium is used in the manufacture of aeroplanes. Which property of aluminium makes it possible for this use? So why would you use a metal which is very heavy for something which is going to be in the air, to be put down, to be difficult for you to fly that thing? So the one which would make sense will be low density. Okay, then 15. Gas X has the following properties: colorless, turns red litmus blue, no effect on lime water, soluble in water. What is gas X? So the moment you see no effect on lime water, then we can cancel out carbon dioxide. Hydrogen, not really, doesn't turn red litmus blue. Oxygen, not really. There's tests that it relights a glowing splint, and the one here will be ammonia. Okay, so ammonia turns red litmus blue. Okay, so I'll give you a trick here to remember this. Just think of RB as ammonia. So find someone with the initials RB and you can give them a nickname of ammonia. Just don't tell them, it's a secret, keep it to yourself, but it will help you to remember RB, that ammonia. So RB means red blue, so it turns red litmus blue, ammonia. Okay, so you can use that on somebody with the initials RB to give them a nickname of ammonia. Hey, it's for exam, so probably they'll understand, and if you don't find out, you won't be in trouble. So 16, which of the following will react with ammonium chloride to produce ammonia gas? So you need, when we are producing ammonia in the Haber process, so ammonia has got this chemical formula. So you see, you need something, an element which has got a nitrogen and a hydrogen for you to produce ammonia. So for this to happen, we have to get one of the elements here should at least have any of these. So which one of them will react with ammonium chloride to produce ammonia gas? So calcium carbonate, calcium hydroxide, calcium metal, calcium oxide. So for this one, we'll go for calcium hydroxide. Okay, so go for B. I will go for B. Which equation represents incomplete combustion of ethane? So an incomplete combustion, what to look for? You look for the elements being produced. This is ethane, quite right, being reacting with oxygen. Then if there's carbon dioxide, it means it's a complete combustion. If there's carbon monoxide, you see, oh, it's incomplete. So in an incomplete combustion, you have carbon monoxide being produced and water, meaning you can still have further combustion taken on by the carbon monoxide can still further react. So the one with carbon dioxide out, so B and D are out, so we have A and C. So A is disqualified because we've got hydrogen gas here, and what we need is water there at the end. So the answer will be C. We go for C. 18. The following diagram shows the structure of butane, an alkane which is manufactured by cracking large hydrocarbons. Which hydrocarbon can be cracked to make butane? So butane can be produced by cracking hydrocarbons. So you can even tell from the word here, they're saying large hydrocarbons. Okay, even though you don't have an idea, but just looking at this, you can tell they're saying large hydrocarbon, a large hydrocarbon there. So here we've got decane, just got C10H22. Then this is methane, propane. So you can see that these three are basically small hydrocarbons, not really large. Okay, so actually the one which would produce butane, this will be decane there. Okay, so 19 and 20, I'm almost tempted to leave them for you to practice. And I just have to mention before that the rest of the questions will be answered in class for those who are registered with us. So you can register for tuitions with us. We have tuitions available for science, and they'll help you further if you think like you need further help, and to get further additional materials and additional question and answers. So we're gonna do section B and we're gonna do section C further in class. Hopefully they'll be available. A few questions like maybe this part will be available on YouTube for free, but most of the videos and lessons, they are available in class. So we'll invite you to join, and you can send us a message use the number on the screen right now to send us a message on WhatsApp, and then we'll respond and we'll give you all the details. So I'll give you the answer to question 20. What is the linkage between the units in terylene? So the linkage in terylene is an ester linkage, and that has to do with carbon double bonded to one oxygen and a single bond to another oxygen. So it will be this one. That will be the answer, which is B. All right, so you can comment your answer on this one, 19. I want to see something. You can comment your answer below in the section, and then I'll probably reply with what I feel is the correct answer, or we can discuss it. So thank you for watching. We'll see you in the next lesson.